So I'm Olivia, and I'm here to talk to you guys about big data. So there was another woman who came up and spoke about data. So shout out to you, data in the house tonight. All right. I'm just gonna use the computer because this is a little weird. So whatever. All right, so my name's Olivia. I'm an undergraduate student at the University of California, Davis. I'm studying computer science, and I'm a Code 2040 fellow. So as a fellow this year, I completed an internship with Intel in Hillsborough. So yes, Oregon and the rain and the bikes, it's all true. And right now, I'm an intern at Intuit. So I'm working on the categorizations team, doing data analytics and machine learning. While I was at Intel, I was working on the platform architecture group, so it was like an internal tools group. And I want to talk to you guys about the project that I built there and some of the obstacles that I found in a big data project that was not classified as a big data project initially. So what is big data? Usually when you hear big data, you might see a picture like this, some graphs, and people just, they come with graphs, but like, what is it? Like, where did you get this information? That's what I wanted to know. I heard it a lot. And so what I found is any business, any company, there's a lot of different business units, right? You could think about legal, you might think about manufacturing or accounting, shipping, and the company keeps records on all of that data. It could be transactions or line items or like when something is being shipped, because all of that could contribute to the business basically making more money or not. Like if a company ships a lot of products on Friday, but then there's a lot of traffic on Friday, so it actually doesn't get to the consumer until Monday, but then Monday people don't like to shop, it could cause, like the company to lose more money. So those are things that I didn't really put together, and I didn't understand that the company has data, like that specific data, in a database somewhere, but no one's really looking at it because a lot of people don't think to ask those questions and like put those frameworks together, right? So so it's really important to ask the questions. Like if you usually coming from the top at any company, someone will say like, oh, we want to make more money, and we want to make more money in this specific business unit, or we want to make more money with green buttons, so do that. And they'll go tell other people in the company like, go make more money with green buttons. So other people have to say, okay, so how do we make more money with green buttons? Do we have green buttons? Like, how many green buttons are we selling? Like, there's all of these things that you need to know. And when you have one question, it's important to keep going with that question. Like, analyze the question and then have another question. Like, never stop at one question. Like, the one question that you have is just the tip of the iceberg. And when you thought you were getting an answer, because you might ask someone a question and then get a response, it's still like, really keep questioning. I'll just leave it there for now, but we'll come back to that. Because during my internship, the company said, okay, we have this issue. There's one database inside the entire company, just one. The company's really cool. There's only one database. So, yeah. So they said, okay, we have this specific data in the database that no one's ever looked at, ever. So we want you to go find this data in the database and tell us what the data means. As ambiguous as that sounds, that was my project. So we're talking about a company that is really, really old and has a lot of data. And the team that was asking me for this data, what they knew about the data is their team name. Like, we have a team named Cupcake. So in this database, go find every single table that is related to Cupcake. Let's break this down a little bit further because I don't think you guys are with me. Cupcakes have frosting, right? We've got flour, salt, sugar. You have to go find all those ingredients in the database, like, just to get one cupcake. It is a lot of data. We're talking like maybe like 150 tables that I had to find. No one knew the names of these tables. So it was a lot of digging. It was like one really hard problem that was broken down down and down. It's like a scavenger hunt. You're like, okay, Mr. Database Manager, I need cupcake data. And he's like, I have a lot of cupcake data, like a lot of cupcake data. Which cupcake data do you need? How far back in the database do you want to go? Because I have cupcake data from forever. But if you want cupcake data that's 3 months old, we have this really fast query that you can use. You can get the data tomorrow. But if you want cupcake data that's 3 years old, you need to do like bit string manipulation. You need to go find like a hobbit in the corner because like nobody has ever touched this data. Nobody knows how to access it. Like it's going to be difficult for you. Like this is like a sort of conversation that was happening. So it's a really hard problem that you start out with, but you break it down, and even when the database person might tell you, or anyone in your solution, in your journey for the answer says, I have this answer for you. And then you go validate that answer. You're like, he's like, the cupcake's over there. And then you go get the cupcake, right? And then you have the cupcake in your hand and you take a bite out of the cupcake. Is it really a cupcake? Is it, right? They tell you that it is, but sometimes it's not. It's like when you guys see this image, what do you see? What? Nike, right? But what does Nike do?
Sportswear.
Athletics. They do a lot, right? Can you think of anything? Does anything stand out when you think of Nike?
Shoes. Oh.
Thank you. Shoes, right? They sell shoes. So if Nike is thinking about data, they probably care about data related to shoes. I mean, there's a ton of questions that could come there, but when you're thinking about big data, Nike has a lot of data about shoes. They have a lot of data about the cushions and soles that make the shoes. They have a lot of data about how people use the shoes, the times of year that people buy shoes. Like the Nike Free, when do people buy the Free more often? All of that stuff is actually really important, and the company has a lot of that data in the database. But there are not many data scientists who are going into the Nike database and gathering that data and using that data to actually make decisions and say, okay, like retailers, I want you to do this specific thing with the Nikes because we have data that says you should do this, right? We need more people asking more questions and getting a lot more critical about the data in the database to make better business decisions. So hopefully some of you will do that in the future. But for me, what I started to understand is it really comes back to like financial statements, right? You start to think about like how much money did this company bring in, right? We thought about Nike. We know that Nike sells shoes, and like it's like how many shoes did they really sell? Like how much money did they make selling shoes? And so you kind of check out the financial statements there to get that information. And even thinking about like an entire workflow, and how this one is not relative to Nike, but I did think that the design process here is very relative to the design process that I went through when designing my project, and even what I would think Nike would go through to design some sort of solution to bring in more money selling Nike Frees at a particular time of year, right? So it's kind of like you have an idea, and then you might go like, oh, okay, let me like ask a question about that idea and find some data related to that idea, and then go check on the data, do some analytics, perform some statistics on the data. So it's not a direct linear path. It's like very like flowy. So that's why I wanted you guys to like see that, just to know like it's never really like one particular question here and then one answer here. It's like very like flowing the entire time. So when we're thinking about like big data, and we know like the term big data now, it actually stemmed from a guy, Doug Cutting, and Google, because Google is the first company who really cared about big data because they wanted to like categorize everything in the World Wide Web, and that's like a huge problem, right? Like all the data like from forever, like that's a lot of data. And so when you're thinking about like big data, you usually think about Hadoop, and you think about MapReduce and HDFS, or the distributed file system. So yeah. And when you're thinking about like where that data is stored, the data is stored in a database. And it's sort of funny because like right here, you have a picture of a database with many servers, and they're all like connected. And this is how ideally you think about a database. But that's not really how it is. Like the database that I worked with was this one server right there. So when you make a query that's like returns a billion records, that one server crashes. And then it all crashes. Like there's only one database. This is ideal. This is not reality. We also need people to design better database solutions because that's not what it is right now. Um, and even when you think about like inside the database, what does it look like? Well, this is like a very baby version of what a schema. So right here we have a schema, and these are basically tables and rows in the tables, right? But it might look like a lot if you're not that familiar with a database. This is actually like, maybe this is like 20 records. The database that I was working with was like 200,000 tables. 200,000 of those, right? And it's like someone tells you like, okay, so go in there and then find all the tables that say cupcake. And they don't just say cupcake, they're labeled like CP1234AZ2X5. So somehow you're supposed to know to find those and make some sense out of that. And even when you're talking about generating revenue, it's really important because all the data that's going to generate that revenue is in that database, and they're in those tables, and all of those columns or rows in each table, they might have really specific information about whatever item that you're looking for, and it could honestly make the company like a lot of money. For instance, the project that I was working on, we were trying to ask a question like, there's a particular piece that's being placed into many products that are being sold, right? And this is like across products. And if there's no need for this piece to be in production, we could take the piece out. And if that piece is not in production, that could save the company like a lot of money, so much money. So in the database, it would tell us like, oh, actually, when we're putting this into production, like, do we really need it there or not? And so project management is really, 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 really important in all of this. But I do want to break down project management from a project manager and then project management in terms of development. Because like in this case, like I was the developer and I had a project plan from a project manager. But I wasn't really able to follow that project plan because there were so many twists and turns that we didn't even account for. We thought the project plan, it looked something like this. Like it was like, okay, so we have this thing that we want to build here, and it should be really simple to build. It should take a week, and then you're going to get to this phase, and then this one, and then this one, and then you're done. It's very like linear. It's very clear. Everything's described like perfectly here, and this is actually what my project plan looked like. This is way more accurate. I mean, I ended my internship with, I think it was like 18 like notebooks full of like notes and iterations, and I think I never even got to phase 2 in the original project plan. It's just really interesting to see how like this, right, versus that. This is what development looks like in big data and data science. And so once you've kind of like, you've asked a question and you found some sort of solution that you're kind of like working toward, you can move your data. So my data initially was just stored in a regular relational database. And when I ran my query, I ended up making an API on that database to like return data because I asked all those questions and I found like a flow that I wanted to execute. So I run my query and I returned 1 billion records, 1 billion. Then my computer crashed, it stopped. I'd already ran it for 8 hours trying to just get these results. And it looked like when I talked to like the database manager about it, he's like, yeah, I think we've got like 17 billion more records in your query, but we couldn't get that far. So this was all in a regular relational database. So this is a big data problem. Clearly, right? It's like a lot of data for this really small question that the team had. But like we actually should have been in Hadoop. It's a big data problem, so we should have had like multiple clusters in racks and run the queries in batch. That's something that I know now after having an entire like day-long conversation with a data scientist. But it's something that a lot of teams don't think about. They'll give you a project and say, yeah, we have this database from forever. Go get the data, give us the data, tell us information about the data. But it's a big data problem. You actually need like big data solutions. It's not just like a regular like SQL relational database solution, right? So when you're working in Hadoop and you're working in big data, there's a lot of different like technology stacks that you can explore and start to like run on your data. You could use like Hive, or you could use it usually all runs on Hadoop at like the base layer, but you could use like Tableau for visualizations. Like right now, I'm working with Intuit. It's a fintech company, and so we use Tableau a lot to like start to make decisions about like how to change our categorization algorithms. So excuse me. And like we're using right now like a Vertica database. There's so many like different solutions and different ways that you can like put the app, like basically the apps on top of like Hadoop together to make some solution that you can gain meaning from your data. And there's just so many different ways to put it together. But I would like to point out that you basically have like Hadoop kind of like flowing through, even though other sides can be like different. And then I want to talk a little bit about like the analytics behind it, because it's not just like a word or just numbers. Like the questions are what are the most important. Like you're using the data to answer your questions, but the questions are what's important. Like when you're making these graphs, like what do those graphs mean? Like what are you trying to prove with those graphs? Like that's like the most important part. And you can prove that with a certain like with a certain visualization. I'm not sure if anyone here has worked in D3, but there's so many different ways that you can visualize your data, like graphically, linearly. You can use like columnar data or whatever. There's so many like different ways. Sometimes like animations might be more appropriate for what you're building, but there's so many different ways. And if you choose the right one, you can really like get the answer that you found from your data. You can convey that to other business units who don't really understand the numbers, and that can really influence them to make better business decisions and really help your company in the long term. And I want to talk a little bit about effective communication, because it is like the biggest lesson that I learned from my internship. So the team that I was assigned to was not the team that I ended up working with. Like for my project, I didn't work with anyone on my team. I had one product owner who was on the database team, and I had another product owner who was he's an architect on another product team. And so I study software, and I worked with electrical engineers and a database manager, right? So I didn't really speak either of their languages. They were literally using terms I didn't know. They had a whole bunch of acronyms and very, very little time. They both had their own projects that they were working on, and mine was like at the bottom of the totem pole. And so one thing that I noticed is when I would come and have a meeting with either of the product owners, they were listening to me, and they were responding to the questions that I had. So it was really important that I did my research and I understood like, okay, so this is what I'm thinking about. Here's the solution that I'm proposing to bring to the table. What do you think about that? And wait for their response. But not just like accept their response and walk away, but to really start to engage and have a conversation about it. Because one thing that I let happen for too long was to get a response from a product owner, accept the response, and walk away, when the product owner would come back the next day and say, actually, I was tired that day. What I told you is totally false. That information makes no sense anymore. And if I would have just like engaged with them a little bit more at that time and said, oh, like, what do you mean by that? How do you actually apply that? Where do you see that in the database? You said that this query would work. Would you show me right now? If I would have done that at that moment, it would have saved me maybe like 2 weeks after each question, just because I spent so much time trying to understand what he said or what was said to me, and as opposed to like having direct conversation about it. So it's really, really important. I would advise you to like, if you have any sort of question about any product that you're working on, like don't be afraid to like go for it and ask the question, because people always say that there's no dumb question, but also like when you don't ask the question, or even if you don't ask enough questions, people might know the information that they're telling you is wrong, but since you don't know, they're not going to be like, oh yeah. They're just like, she doesn't know, so just go ahead. That's it. Thank you.